Okay, moving on to 3-8. Here you're going to be given a situation. Write a cosine graph for the situation and then answer some questions that you have to use calculus to get the answer to. So the trig function that you have to get familiar with is cosine. So let's do a quick review of cosine. And if you remember, back about almost this time last year when you were in trig, we were graphing all those trig functions. And if you remember, cosine started at its max, crossed the axis, went down to its min, crossed the axis, finished at its max, and then it just kept repeating itself. Okay, and then all the way through that chapter we started shifting these things around, stretching them out. So if we move the graph, let's move it over here, over and up. Okay, still cosine. All of the changes we make were found in the four variables. It was c plus a cosine b times x minus d. Okay, this c value was your vertical shift. So if you had a plus c, you went up. If it was a minus c, you went down. And the c value is where your axis ended up. So here, our axis value was the x-axis, so that had a c value of 0. It wasn't shifted up or down. So on this one, you would want to find the middle. And by middle, I mean halfway between the max and the min. We want right through the middle. That's going to be your c value. Okay. The a was your amplitude. And that was the distance from the axis to the max or the distance from the axis to the min. So it's how far apart the max and this axis are. Or you could go from the axis to the min. Those are going to be the same because that axis is right in the middle. And then that was your amplitude number. So from axis to max or min. Okay, we'll come back to the B. The D was your phase shift. That was your left and right. If you had a minus D, that went to the right. And if you had a plus D, that pulled it to the left. So normally, that max is right on the y-axis unless it's shifted left or right, and the amount that it's shifted is your D. That distance over, how far over it is your D. Now back to B. B was the number that affected the period length, how long it took to complete one full cycle. So from here to here, from max to max, is considered a full period length, and 2 pi divided by B equals that period. So the B affected the period. It wasn't equal to the period. So what you're going to have to do is give it a situation now. Come up with the equation all on your own, and then we'll do some calculus to answer some questions. So let me give you the first situation. I think I want to start a new paper so I can fit it all on there. And we're only doing 2 examples today, but they're kind of complicated. So we've got a mass is bouncing up and down on a spring hanging from the ceiling. So a mass is bouncing on a spring hanging from the ceiling. And you are going to write an equation for y, where y is going to give you the distance in feet from the ceiling to the mass. So it's the distance from the ceiling, not the floor, in feet. And t is going to be in seconds. So if you think about it, you got this ceiling, you've got a spring, and you got this weight, that mass on the bottom, and as you pull that and you let it go, it's going to bounce up and down, and that distance from the ceiling gets bigger as it goes down, and it gets smaller as it goes up because it's getting closer. So it's going to make that nice cosine graph. So this is what we know. This particular mass, the mass makes a complete cycle every 1.6 seconds at time equals 0.4 seconds. The mass is a maximum of 8 feet, so y is a maximum of 8 feet. So the farthest it gets away from the ceiling is 8 feet. The minimum distance is 2 feet. I want you to sketch the graph and write the equation. Okay, so your goal is to come up with the A, B, C, and D values. So let's take a look at sketch the graph first, and then these values kind of fall into place. Hopefully they fall into place. Okay, so we are starting, it says that at time equals 0.4 seconds, y is at its max of 8 feet. So if I call this 0.4 seconds, let's go 0.1, now I'll go 0.2, 0.4, it's at its maximum of 8 feet. 2, 4, 6, 8 feet. Okay, and if I think about this, it tells me that it makes a complete cycle every 1.6 seconds. So that means it's going to finish 1.6 seconds after this. So where's that going to put me at? If I add 1.6 to that, it's going to finish at 2 seconds. So 0.2, 0.6, 0.8, there's 1, 1.2, 1.4, 1.6, 1.8, and 2. 2 seconds. So it's going to finish over here again. So it's not imperative that I get this perfect here, but so it hits its max, and it starts coming down, finishes, its bottom is at, how low did it say? Minimum is 2. So it's going to hit the min down here at 2, and then go back up. Guess it wasn't necessary that I put all those in there. I might not hit that at the right spot there, but that's okay. So everything we need to figure this out is in here. Alright, let's go. I guess it doesn't matter. Let's start with the vertical shift. Remember, vertical shift is this axis in the middle. The vertical shift is halfway between the max and the min. Well, my max was at 8. The minimum it got was 2 feet from the ceiling. So what's the middle of 2 and 8? So you want to find the average of 2 and 8. Well, if you average those, you're going to get 5. So our axis is at 5. There's our C value. So the C value is 5. It's the average of the max and the min. Maybe I'll put that in there. 8 plus 2. We want the middle. Okay. Now the A is your amplitude. Remember, amplitude is the distance from the max to the axis or the axis to the min. They're going to be the same thing because that axis is right in the middle. Well, 5 to 8, that's a distance of 3. So your A value is a 3. Your D is the phase shift over. Normally the max starts on the y-axis unless it has phase shift, and this does. It got pulled over. So my phase is at that 0.4 seconds over when they started timing. So my D is a 0.4, and it's going to be a minus 0.4 because it went to the right. And now I got to figure out the B. B is not equal to this period length. It said it took it 1.6 seconds to complete. Two pi divided by B has to equal this number. So we got to do a little bit of math to find the B. So 2 pi divided by B has to equal that period length of 1.6 seconds. Well, I like to think of these as proportions. If I put a 1 under here, it's just cross multiply and divide. So 1.6 times B equals 2 pi. So B equals 2 pi divided by 1.6. So if I take care of that ugliness, I'm going to go 2 divided by the 1.6 just because I really don't want a decimal within the fraction. But I want to keep the pi in there. I want to keep it exact. So I'm just going to go 2 divided by the 1.6. 2 divided by 1.6. 1.25 pi. Okay, so I've got everything we need to write the equation now. So it's y equals, C came out 5, amplitude is 3, cosine, B we calculated to be 1.25 pi, phase shift is x minus 0.4 because it went to the right. Okay, remember y is distance from the ceiling in feet, x is the time in seconds. Okay, my first question, call it part A. How fast is the mass moving at 1.4 seconds? Okay, remember, this is a distance time graph. If I was to put 1.4 into this equation, that's just going to tell me how far away from the ceiling it is. It's not going to tell me how fast it is. So when you see how fast, that's a rate of change, you know that that's velocity, and velocity is the derivative of distance. So we've got to do the, let's see, we've got to do the derivative of distance to get the velocity. So, derivative here. Be very careful here. I think it's best to distribute this in. Otherwise, there's